Okay, maybe. Maybe we're live, I think. Not totally sure. This is absolutely 2000% brought to you by Rockstar. Mm. There's been a lot of Rockstar this weekend with all the stuff I've done around the house, all the stuff I've done with the limo, all the stuff I've done with the other cars. So definitely been enjoying Rockstar. So tonight I want to show you guys. We talked a little bit about it before with with the basic electrical stuff and some of the things, the tools you need, and to not be fearful of normally 12-volt electronics. When you start getting into 240 and into three phase and stuff like that, that's when you start doing safety gear. If you're riding around in a helicopter in a Faraday cage with a big ass stick and you have to touch the 200,000 volt power line with your stick to ground out before you get on that power line, you're probably not watching this video because those guys have some serious mental issues. That's insane to me. Hey, Liz, um, those guys who do the high power line inspection and repair, and the pilots that get them on those lines, you guys are bonkers. I think you're awesome, but you guys are absolutely crazy. So uh, we're dealing with 12 volts, and usually, for the most part, less than 20 amps. Usually, okay, let's say less than 40 amps. So if you're going to get juiced, it's going to hurt for a second, and it probably won't turn off your heart or barbecue you. Um, so this stuff, again, don't be too fearful of. But we had talked about doing the actuators using two relays to work the actuator. And I found some drawings that I put in the previous video that would have worked and did work, but I wanted to clean things up. So I got some test leads and I started playing around with the relays and trying to do fewer connections with a cleaner operation. So literally a key off, it moves the actuator, a key on, it moves the actuator with less, and the relays only work when activated. And the relay, the actuator actually has a switch, a limit switch, so it turns itself off. It turns power off. So I looked for something a little bit cleaner, and I did a bunch of testing with my stuff, and then while I was searching around, I found this great drawing on I think it's called the 12volt.com, and it's exactly what I'm looking for. It's basically it's like a power antenna in a car. I know a lot of people won't remember that, but power antenna in your car, you turn the key on and the power antenna raises up, and then you turn the key off and the power antenna goes down. So it's basically what we're doing here, but we're using our own relays. In those units, they use what's called a double pole double throw relay, and it's built in, and that's normal operation for those type of things. So what I'm doing here is I'm making my own double pole double throw relay from two single pole double throw latching relays, and these work great um, because you can do a whole bunch of different things with them, and also they don't care which side is positive and which side is negative. That's what comes in handy when you're doing an actuator thing like this, because if you're running it backwards, if you're sending positive to the ground side, it's okay with that. It doesn't care. It's not like a diode that's kind of a one way. We can get into diodes later and one way power and all that stuff. I wanted to show you guys what I came up with, and with the help of 12volt.com, and I'll show you the drawing. Hang on a sec. Let me grab the iPad that's over here. God, I hate sitting on concrete. So I'll show you guys the drawing I didn't come up with, but I found. And you guys can screenshot this if you would like. I'll try and make it nice and big for you. If I can find the link again, I'll put it in there. But this is the cleanest and simplest way I found to do what I'm trying to do with these relays and with this antenna. And I'll sort of try and describe it just really as simply as possible. Yep, my old caddy had one. Yeah, the power antenna. This is basically what that is. This is basically a power antenna switching system, but they have their own double pole, double throw relay in the antenna housing. It's the only real difference. So I'm going to come over here and I'll see if I can get you guys a little bit closer. I'm going to have to tilt down because that's how this camera works. And I'll try and get more in the shot too. So 12-volt battery, fully charged. This is a NOCO lithium-ion battery. This is my little shop test battery. It was going to work in the Miata, but it wasn't working in the Miata. So reason it is a shop test battery. It's got tons of attachment points here. It's a great little battery, and it holds charge forever and ever and ever and ever and ever. It's great. And it doesn't really care if it sits on concrete. It charges very quickly too. So according to that diagram, you can see what I've done. This is basically that diagram. And I have these test leads so that I can change things very quickly. I'll show you what one of them looks like. So they're these little guys. And they're rubber with alligator clips on the end, so you can clip them onto stuff. And they come in a bunch of different colors: red, black, green, yellow, obviously. These are great for testing stuff because if you want to, you can just go, bink, oh crap, okay, that doesn't work, or bink, hey, that does work. You can yank it off really quick and not really cause any harm, maybe blow a fuse. So that's why these are great. And if you want it to stay put, you can actually, I don't have anywhere to clip it onto. You can actually just clip it onto a wire like it is on all of these connections. So we have our grounds. Now, of course, I ran out of blacks, so I used green and yellow. And these are all of our grounds. Red, I tried to keep red with all of the positives. So everything that's hot, including our switch, this is technically our switch, these are all hot. So the actuator is currently all the way up. You can see it right here. Here's the license plate. Here's our actuator wire, and these are our two leads for the actuator. So they come off the relay, off number 30 off the bottom, and that's where our signal goes. So I don't need to test it out because I've already did it, but I want to show you guys how this works. So my two reds coming off of the actuators. The actuators are the relays are getting power from the main power source, and I have a 40 amp fuse in here, which is way overkill for this. But if I was normally running this, I'd run a 10 or 15 amp, maybe a 20 amp. It's very low. Anyway, so the relays currently have power. They have 12 volts to them right now. Both of them do. Now I want to switch those. I want to latch on one and I want to unlatch on the other. So currently, let's see, black, which is this guy. This guy is currently latched closed and he's sending 12 volts to this. This goes up to the actuator, and the actuator has a limit switch, and when it reaches all the way up to the top, it undoes. So now you just have 12 volts hanging out up here, waiting to be told what to do. Actuator doesn't care. It's closed, whatever. So now we want to switch. We want to open this relay, or sorry, I keep saying actuator, but it's relay. We want to switch this relay and switch this relay. So we want this guy to open up, and we want this guy to close down. Now, when this guy opens up, that relay up at the top of the actuator, he's going to stay open. He doesn't He doesn't really, or actually, I think he's going to close. Yeah, the limit switch is going to close, but we've lost power here, so we have a short, and so he's not going to do anything. Now we have power here, which is sending it to our red wire on the actuator wire, and that is going to lower the plate. When it gets to the bottom, that limit switch is going to open again on the actuator, and this thing will still be sending power, but we're open and there's no power. So technically, this is our key. So we have power from your car battery or whatever power source you have, but it's full-time power. It's always on. There's very, very little load draw from this. It's not pulling a ton of amps. It's barely using anything to stay latched. So it's not a huge power drop. If it was continually, trying to pull that actuator up, you'll burn out your battery, you'll burn out the actuator motor. It'll be bad. So that's why it has that limit switch up there, and it turns it off. And also at the bottom, so it turns it off. So this is our key. And this is what happens when you turn the key in the ignition, and you're going to go to on. So right now the car is off and it's parked and we're having a great time. Now it's time to leave. We obviously air up the car, and now we're going to turn on the car. And this is so hokily mounted. The license plate is going to drop down. Now we drive the car. We're leaving this. Sorry, this is gonna, I should have just clipped it on. Okay, there we go. It's gonna be like that as we drive the car because our key is on, driving, everything's happy. This is not waving around on a piece of PVC like it is currently, but it's fully visible. The state, the plate, the registration, everything's visible. Obviously the throw for the actuator is not a complete license plate. It's about half an inch less than a complete license plate. But that's like a $500 actuator, so I'm going to keep it. So now we're driving to wherever we're going. We're going to turn off the car. That's our off switch. And the license plate is automatically going to retract because we're still attached to 12 volts here. We've just changed that relay from open. We've now opened this one and we've closed this one, which sends power to the appropriate wire for the actuator here. So that's how it works for the actuator wire. So then we're going to turn our car on again. And then even if I turn it off mid-stop, it's going to go, sorry, big mosquito. It's going to go right back up. So it always defaults, I shouldn't say defaults, wherever it's getting power from, it's going to go to. So if I start to turn on the car and change my mind, it'll go right back up. If I leave the car on the entire time, it's going to stay down the entire time. But once it's down, you hear it click off. It's not drawing power now. That micro switch is open. 12 volts is just kind of hanging out in the air. It won't use 12 volts until I pull this off and these two relays switch. That one opens, that one closes, and it gets power to the opposite side. That's it. Now, the reason I went with this setup versus the other ones that I showed you guys was this one has a much cleaner setup than the other two. And the other thing is the other two were working off of a remote. So like when you get a remote like this that has buttons and you have a controller, which is basically a little relay power send, you can use this to turn or to make the plate go up and down using a setup like this with different wiring to the relays. That's what they previously had in the car, was a remote like this. They would hit a button and the plate would drop. Now that's great, except that you're leaving the event and you forget to drop the plate, and now the officer can't see your plate. He sees that you kind of have one, but he can't see your plate. You're going to get pulled over, promise. So this now is just automatic. Every time you turn on the car, you're now legal. Obviously, this is going to have an aluminum tube and a nice frame behind it. This was just a piece of PVC pipe and some red duct tape and a little bolt up top there. This took less than 60 seconds to hang this here. So it'll be like this. And then, like I said, when you turn off the car, and this is just a lot cleaner. There will only be, there'll be a single wire for the actuators that comes out. And then it'll be one big jumper wire for the grounds and another jumper wire for the switch, and then the one power wire. So we'll technically have 4 wires coming out of this in total. And let's see, 1, 2, 3, 4. Yeah, and 2 of them are power. Now here's the other cool part, and I'm just going to move you guys back because I need to move because sitting on this concrete sucks. So the other cool part is right down there, right in front of the rear wheel, is where the fuel pump is. Now the fuel pump is keyed. So I already have power more than halfway back through the car. So I have switched power. So I can run power off of that fuel pump. I can steal power for this relay. I can steal keyed power, sorry. And then for my main battery power, full-time power, I can do the battery that's going to go in the back of the trunk. So I can run it shorter wires. I don't have to run wire all the way up to the front. That's the cool part. I already have wire coming 2/3 of the way back that's keyed. It should work very, very well. The actuator doesn't care where power comes from. It cares that it gets power. It needs to have the common ground. That's probably the most important part. So that should work really well. Even if I have to run regular power, I can still, well, it doesn't, I should say, it doesn't care where keyed power comes from. That's a better way to put it. If keyed power comes from somewhere else, that's fine. Main power should come from the same battery. So when the battery's back here, it'll have the ground and the power from that battery. Keyed power, it doesn't care. So it's going to drop down like that. Key off, turn the key off, closes it. That switch loses 12 volts, but this gains 12 volts on this side and raises that up. So that's it. That's the super simple wiring. When these relays go back into I'm just going to pull this fuse. When the relays go back into their housings, I'll show you the wiring and the jumpers. Like I said, I don't know where the little box is. I have a little box of spare wires, and I use them for jumper wires. Really handy. And we won't be using insulated terminals. We'll take those terminals, we'll take the insulation off. Wires will go together, and then they'll get crimped in there. And then we'll do heat shrink over them, except for the actual contact part of the terminal. Super clean, super safe, and should prevent corrosion. And with this thing, I need it waterproof as much as possible. So we'll get it water resistant and all that. Plus the relay board is actually going to be off the floor. So even if water does go on the floor, the relay board will be all the way up and we don't have to worry about it too much. That's the trick. So I'll come back and I'll show you guys with 2 relays, 1 actuator. I thought that was a funny title name. And if I can get a thumbs up or a sub for the title name, I'll take it. I don't care. I'm a whore. I don't care. I thought it was funny. I'll come back. I'll show you guys how that relay package sets up, and we'll see how clean I could get the wiring on that. Just, you know, when you're doing testing like this, it's not always optimal. And, you know, these little skinny 18 gauge, 20 gauge wires, again, we're not running a lot of voltage, you're not running a lot of amps. It's great for testing, but it's not going to work for, you know, any kind of professional installation. You need it to look, hey, buddy, little bug flying across there. You need it to not only look really well, really nice, but in order to be A-team, you need it to work perfectly too. So when we get all this stuff, you know, wires cut, tinned together, trimmed up, connectors on, that's when you'll have a really, really nice setup. And then we have a whole bunch of this. This is basically doorbell wire. If you've ever wired a doorbell at your house or someone else's house, this is a shielded 20 gauge and 20 gauge solid braid. This is solid core with braid. And you can shape these guys, which is pretty cool. And this is great for actuators. And when you have, it's basically actuator wire. I think this has 5 wires coming out of it, but we're only using 2. And so for stuff like this, very small gauge when it's all together, and having the extra insulation with it being exposed is always nice. So we'll run, this is just a jumper. I have like 30 feet of this. We'll run this for the actuator all the way up to the relay. This guy will have his own plugs. Everybody will have their own plugs. So yeah. So that's how it works. Hopefully this was helpful for you guys. Also, when you're looking for wiring diagrams on what you're trying to do, definitely check around online. Do an image search, Google or whatever your favorite search engine is. It's hard because there's a lot of misspellings and mislabelings and all of that. But try to work through that and see if you can find what you're looking to do. You know, type in the best description you can, and you'll probably come up with something extremely close. But again, don't be afraid to test stuff, you know, tap it together. Again, you're working with 12 volts, maybe 20 amps max. Oh, that's not it. Okay, there it is. Now it works. Don't be afraid to test it out. And if you are afraid, get some nitrile gloves. That, you know, will put you at ease too. But don't be afraid of this stuff. DC is very simple, and just as a fun fact, remember I was talking about those guys who walk on the power lines? All the power in those power lines is actually DC, believe it or not. That's why you have those huge transformers outside on the street, those big trash can things up on the pole. Those are called transformers. And those are packed full of oil. And those are actually pretty amazing. Those transformers, they put out an incredible amount of heat, and when they blow up, it is spectacular, man. It's a huge firework. So anyway, all the power on those huge power lines is DC, and then it comes to those transformers, and those transformers change it over to AC for all the houses. So there's a fun little fact for you. So those guys are working with DC, and if they do it, you can do it, right? Just practice. Another option, if you're absolutely terrified of 12 volts, you can do a 9 volt. And I'll prove that. Hang on, watch this. Whoa, is that yank stuff off? Okay, so if you're terrified of working with 12 volts, let's do this. This will be fun. Come here. So we're going to take a 9-volt battery. This thing will stay clipped on. These things are really slippery. So we're just using a 9-volt here. All right, he's not going to stay on there. And I'm going to clip this guy on here. And oh, he didn't go? Oh, because he's going the wrong way. Hang on. Now, if you go, I'm just using a 9-volt now. It's a regular Energizer. You can hear how much slower it is, but it's still working. And I'm not really, nothing's getting hurt too much. Now I have to switch the leads if I wanted to go back up. So there it goes. So if you want to, you can also use a 9-volt and just play around with that. There you go. So 12 volts is okay. And this is actually meant, the actuator is meant to operate at 12 volts. So actually, I think it's 14, 12 to 14, 11 to 14 is what it is. But it works on 9 too. So most of the stuff you can do with 9. If you're doing LED lights, you want to be careful running under voltage, but it'll still give you that, hey, this is wired correct or this is not wired correct. And 9 volts is really hard to hurt.